Welcome to this short introductory video demo of Virtual Instruments LDX Enterprise, the most advanced storage performance test solution on the market today. LDX Enterprise is designed to help storage professionals to optimize cost and assure performance by more intelligently selecting and deploying storage infrastructure. The Enterprise platform is a combination of a hardware appliance for massive load generation and software for performance profiling, workload modeling, and analytics. In addition, you can easily acquire workload metrics from your existing storage array through our workload data importer software to automatically build realistic workload models. With Virtual Wisdom, we have another great source of workload data, the data collected via the Virtual Wisdom performance probes. This data is programmatically ingested into Enterprise for extremely realistic and scalable workload models. Before we begin the demo, let's look at the most common use cases. The Enterprise product is used to solve many problems corresponding with the lifecycle of file block or object storage infrastructure. Typically, the lifecycle starts with technology evaluation, then product evaluation. Once you've selected your platform, you can optimize your configurations. Once you're in production, you can use Enterprise to identify and fix problem workloads. And finally, you can mitigate the risks of changes by testing them in the lab before you deploy to production. So let's get started with the demo. Here you see the LDX Enterprise homepage. This dashboard replaces the command line interfaces, limited GUIs, and scripting that you were forced to use in legacy test tools. The basic workflow described on the homepage starts with the setup, where you add appliances and define test beds. It also includes a preconditioning workload for Fiber Channel and iSCSI systems. Next, you can import production workload data output from Virtual Wisdom or your storage arrays and perform an analysis of the workloads. The workload data importer allows you to import a CSV output from a storage array or any other capable device into LDX Enterprise for characterization. In the next section, you create model workloads that you use to generate workload tests against the storage arrays. In addition, you can define suites that will automatically run a high number of individual workload tests. And finally, in this section, you can see your test results, highly visualized key performance indicator graphs and charts, and detailed statistics. Next, we'll look at our test bed. A test bed consists of the target array in our lab and the LDX load generation appliance it's connected to. For this simple demo, we'll use a single Fiber Channel port to our RAM disk test bed configuration. The client represents a single port on the LDX appliance mapped to a single LUN. In the real world, this appliance can drive many ports and millions of IOPS. I want to stress this point. This appliance replaces the racks of physical servers and sometimes hundreds of VMs you used to have to use in order to build a realistic, scalable test platform. Now I'll select Workload Tests from the menu. Each workload test represents a specific workload to be used in a performance test. We'll look at the Fiber Channel workload that comes standard with the Enterprise software. I cloned it and added video to the end of the name. We can see how easy it is to edit. This workload reflects the application workload that is running on our production system. You can edit the parameters by moving sliders or from menu pull-downs. It's pretty simple. Here, I'll change the write access pattern from 50% random to 75% random. The rest of the workload parameters are just that easy to modify. Block size distribution, offsets, MPIO, error handling, and the like. I can select data content by the pull-down. In this case, I'm not testing a flash-based system, and I'm not going to use compression or dedupe. But you can see how easy it is to change my ratios. Because this is just a demo, I won't run the pretest, which normally handles preconditioning. Next, we can specify the number of concurrent workers and ramp up and ramp down values. Finally, I'll run this test for 5 minutes, though in the real world, you'll run a test for much longer. Lastly, I'll ensure that I'm running this test on the target array we set up in our test bed, and update the test to save any changes. Once we've finished with the workload settings, which can be used to perform Whatif Analysis or to find the breaking point in an array for our specific workload, we run the test. And we can watch the results in real time. Here's an example of the standard key performance indicators you might review: IOPS, throughput, and latency. You don't have to go scrambling to find log files or combine dozens of HTML files and fire up separate reporting tools. It's built in. As you can see in this report, for this workload on this array, latency would average less than 1 millisecond. I might have similar workloads for NFS or S3 protocols or for Oracle or VDI applications in my project library. We typically derive the workload parameters we showed earlier from the output of standard array monitoring tools, which are used to create CSV files and which are available on every storage array from every vendor. So that's it. We're done. We configured a test bed, ran a fiber channel test, and viewed the results. But if you'd like to see a very cool feature, stick with me for just another minute. Let's jump over and look at an iteration suite. If we wonder what performance on an array would be if we were using different queue depths for different block sizes, it's simple to test. Here's an iteration workload developed by my friend Darren. He's selected different queue depths and block sizes and is running 96 tests, or iterations, from a single command. He'd like to see throughput, IOPS, and latency for these values and find the sweet spots for this target array. I could just as easily add many other parameters such as data reduction ratios, for instance. I'll start the test and let it run and view the Iteration Explorer once it finishes. And we generate a report that looks like this. Our Iteration Explorer graphically shows throughput, IOPS, and latency for, in this case, 8K blocks. And latency figures are pretty close. So I'll select 16K blocks and take another look. Here, queue depths of 8 and 256 might not be good for 16K blocks, and if we look at all three key performance indicators, well, 32 appears to be a pretty good setting. So, to summarize, we did a what-if performance test using the Workload Iterator feature, generated a report, providing the data for analysis, all with a single appliance, an easy-to-use GUI requiring no scripting or complex setup. Our goal is to simplify the life of the storage engineer and architect to help them make more intelligent storage technology decisions that optimize the cost and performance of storage deployments. Thanks very much for watching. For more information or to see demos on building application-specific workloads, composite workloads, comparative storage technology tests, configuration optimization, or change validation, go to virtualinstruments.com and click on Resources.